All right. Hello and welcome, everybody. Today we are going to do section 2.4 in geometry, which is all about algebraic proofs. So what we're going to do is we're going to learn how to use algebraic properties to solve an equation. We're going to learn how to explain our steps. So that's the important part, is the explanation. So we're taking a bit of a turn from what we're usually used to doing, of like we want to get a solution and that's the answer. It's all about how we justify our steps. So that's going to be our main focus of today. Algebraic operations that we already know, but again, it's about putting the name to the specific operation that you're using and justifying it. So you have a sheet, you should have a sheet that lists out all of these key properties that we're going to be using. And it starts off with these four, which are algebraic properties of equality. Sorry. Properties of equality. So there's the addition, subtraction, multiplication, and division property of equality. And what these things all say is that if you have an equal sign, so each of these is describing A equals B. If you have two things that are equal to each other, then you can keep that equation balanced if you, the addition property of equality is saying, add the same thing to both sides. Now it's just A plus C equals B plus C, still equal. You can subtract the same thing from both sides. C is this thing that I'm just adding or subtracting, or doing whatever. Multiplication property of equality says you can multiply C to both sides. And of course, division property of equality, you can divide C on both sides. So it's something that we do very often when solving algebraic equations, but this is just the name that we're giving to it, the addition property of equality, and so forth. So just keep in mind, again, the property of equality just allows you to do the same operation on both sides. It keeps the equation balanced. We're just putting a name to something that we know. A couple more properties. Substitution is one that's going to be very helpful a little further down the road, where if two things are equal, you can substitute one in for the other in an equation to help you solve something out or prove some point. And then also you have the distributive property. So we know this as well, as if we see, in this case, A is multiplied to the binomial B plus C, you can distribute it out to get you that. Similarly, if it's A times B minus C, you can distribute it in again, multiply it. That's what we need to solve these algebraic equations. So now let's see the format that we're going to be using to do these. And again, it's not about the final solution. It's about the journey. It's about how you get there. So we have this equation, 3x plus 2 equals 23 minus 4x. Justify each step in solving. And this right now is a 3-column setup where we have the equation, the explanation, and the reason. So the equation is going to start off with the equation that we're given, which in this case is that. Great. The explanation is saying, why did you do that? Why are you able to put that? Just in your own words. There's no formal rules or laws here. It's just like, in your own words, what happened here. And what I did here is I just wrote the given equation. So I'm going to say, just write the equation. There's nothing like formal to that. It's just I wrote the given equation. And the reason is where we get a little more formal. It's how we're justifying what we're doing. And if there's a property or a theory or something that we use there, we would put that here. In this case, starting off these situations given as what's what you're given. It's the equation I was given, so that's what I did with it. Now, if you haven't already, please do make sure you have these 3 columns set up in your notes as well, as we'll work through them. Now you have to say, what are you going to do to get from 1 to 2, and how can you justify it? So in this case, there's a bunch of possible solutions, possible kind of paths you could take. What I'm going to do, I'm going to subtract 2. You could have gone a different route, but that's what I'm going to do. When I subtract 2 on both sides, I should say on both sides, not subtracted over, I have it cancel out. Now I'm left with just 3x on the left side. And now I'm going to combine those and make it 21 minus 4x. Kind of doing 2 steps in one there, but that's okay. The main thing I'm focusing on is what I did is what I wrote in red is I subtract 2 on both sides. And that on both sides is a giveaway that this is a property of equality. Specifically, this is the subtraction property of equality. And we use property of equality a lot, and that's a lot of words. So I shorthand it POE. Let's keep it going. So that's all about how I got from the first to the second. Now it's going to be how I get from the second to the third. And what I'm going to want to do algebraically, I think adding 4x to both sides would help me out a lot. And when I do that, I'd be left with 7x on the left, and that's going to cancel out and just give me 21. And again, you might be excited and be like, oh, okay, I'm pretty much there. I'm done. Like, I have the answer. Remember, it's all about justifying. So it's about your second and third column more so than your first. So what I did was I added 4x on both sides. And again, the giveaway on both sides. That's a property of equality. And in this case, it's the addition. POE. All right, basically there, last step, we already know what to do. We're going to divide by 7 on both sides. When I do that, I'm left with x equals 3. And don't think, oh, I'm done. I got my answer. No, remember, continue. It's about your second and third columns, really. And I'm going to say I divided by 7, common phrase, on both sides. And again, on both sides means that's a property of equality. Done. Great. That is your first algebraic proof. We're showing our algebraic reasoning, why we're doing what we're doing, and why we're allowed to do it. We're going to do a couple more, adding a little bit here and there, a couple more together, and then I'll have a couple for you to try. So let's jump in. Again, we got another equation here. Now, in this case, it is, I'm going to just jump right in because I know it goes here. That's a 7W. So I have the equation that was given to me. I'm always starting out with that. The explanation, I'm going to say just write the equation. Yeah, you want to think of it like, how did I get to this point? How did I get to the point of where I wrote in step 1 is I just wrote the equation. I just wrote what was given to me. That's it. And again, the reason is given. Given's going to start you off because you have to have something to start with. Now to solve, we'll see a new property working in. What I see I want to do, thinking my algebra skills, is I want to distribute that -5 into both terms of that binomial to get me -35W minus 40 equals 30. And explanation is just writing like, what did you do? So what I did is I distributed -5. That's all, right? This is in your own words, like, what did you do to get to that step? And the reason why I can do that is the distributive property. Cool. That's the 5th one on our sheet there. And from here, it's going to look pretty similar to that first one, but let's go through it. Again, how do I want to solve it out? In this case, I'm going to add 40 on both sides. When I add 40 on both sides, I'm left with just -35W equals 70. Now, again, I want to note, I wrote here on both sides. Notice I did not write that in number 2. I didn't distribute it on both sides. I just did it here. Sorry, I just did it on the third step. I did on both sides. That's why this is the addition property of equality, whereas the second one is not a property of equality. Last step, we already know it. We want to divide by -35. And I get my solution, but don't stop there. Write what you did. And it's an on both sides. That is the division property of equality. 2 down. Looking good. All right, we're gonna do one more together here. Then I got a couple kind of like this for you to try out. This one that we're gonna do together is a little bit different. So here's a situation. You get a raise at your part-time job. To write your raise as a percent, use that formula given, where P is your previous wage, R is the percent increase as a decimal, and N is your new wage. So you have 3 variables here. You want to solve the formula for R, and a reason why you would want to do that is this example here. You want to know what your raise written as a percent would be if your hourly wage increases from 725 to 754. So you got this raise. You want to know what percent raise that is, because that's important in knowing, hey, was that a good raise or was it not? So in the end, what the question is asking for is can we rearrange the equation and solve for R? That's our goal. So we're going to set it up in the same format and see what we can do to solve this out. Same start we had before, but in this case, my equations just got a lot more variables involved. So here's my equation, and I'm starting off the same way. Let's get right in the equation. And the reason why I can do that is because it was given to me. Great. Now, again, with all these, you got paths that you could take. You could do it slightly different ways. But what I see, and maybe what jumps out to you, is wanting to distribute that P in. My goal is to solve for R. R is this. It's inside the parentheses. It's got that thing multiplied in. It's added to 1. So I need to kind of get it by itself. But I see a way that I can make this a little easier to manage if I distribute the P in. I distribute P in, I get that. PR plus P equals N. And I distributed P. And the reason why I can do that is, again, the distributive property. Great. Next step. Again, keeping in mind what my end goal is. I'm going to circle it in green again. Okay, R. My goal is to get him by himself. Right now he's being multiplied by P, but before I get rid of that P in front, I want to get rid of this one. Once I get rid of that, now I just have PR equals N minus P. And I shouldn't say I got rid of it. I subtracted P on both sides, which allowed me to minimize what I have in the left. So what I did is subtract P on both sides. And again, on both sides, subtraction POE. And I'm really close, actually. Keeping in mind, my goal is to get R by itself. I'm almost there. If I just divide both sides by P, I'll be done. Be careful. Do not try to cancel the P values on top and bottom out. That does not work that way. N minus P is a binomial together. You'd need exactly that on the bottom to cancel out. And this is going to be the division POE. There we go. So this is more of a general equation, more variables, but it's really the exact same thing we've been doing. All right. These can take a little bit of time, but that's okay. You'll appreciate the process and you'll be a pro at it in no time. I have 2 examples for you to try out right now. So go ahead and pause the video and give it a shot. When it's done, I will show you the results. So pause it. And here's what your answer should look like. To that first equation. Keeping in mind, you could do it some slightly different ways. You actually could divide by 3 on both sides first. But I did distribution and so on and so on. And then the last one is just a quick 3-stepper. I multiplied by 2 on both sides to cancel the 1/2, then divided by H. That's it. All right, guys, great job working through this.